Okay, in this video, we're going to be reminding you how to simplify radicals. For a warm-up, it says list the perfect squares, cubes, and fourths. So all your perfect squares will be 1 to the second power, 2 to the second, 3 to the second. So 1, 4, 9, 16, 25, 36, which is 6 squared, 49, 64, 81, 100, 121, and 144, and so on and so forth. Your perfect cubes, 1 to the third power, 2 to the third power, which is 8, 3 to the third power, 27, 64, 125, 216, 343. 8 times 8 times 8 is 512, 729, 1,000, and so on and so forth. That's through 10 to the third. Your perfect fourth root or fourth powers would be 1 to the fourth, 2 to the fourth is 16, 81, 256, 625, 1,296, 2401, and 4,096, and that'll be enough of those. Okay, the parts of the radical. The nth root of a real number a can be written as a radical expression, as you see here, the nth root of a, to where the n is called the index. And that tells you what root you're taking. Are you taking a second root, a third root, a fourth root? Now, if there's no number there, if it's just the radical, it's understood to be a second root or a square root. You have your radical sign. Looks like a little house top there. And then the number inside the radical is called the radicand. If there is no index, again, we assume that it is assumed that 2 is your index. Or you can put n is equal to 2. So nothing there, it's understood to be 2. Say give all the possible, and notice it says all the possible, so we are going to do the positive or negative. What I mean by that, what two numbers multiply to give you 16 is a positive or a negative for? So that would be all the possible roots. Square root of 121 could be positive or negative 11. Now, if it only asks for the principal, sometimes you're not worried about all of them. Sometimes you're only worried about the positive one, and that's called the principal root. But since it's saying give all of them, we are going to list them both. Square root of 289 is positive or negative 17. Anytime you find the square root of a fraction, again, you simply find the square root at the top and then the square root at the bottom. You can split it. The third root now means what number can I multiply by itself 3 times to give me an 8? That'd be a 2. Now, you got to be careful because negative 2 is not a solution, because if you multiply negative 2 times negative 2 times negative 2, you actually get negative 8 and not 8. So third roots only have one answer. So the cube root of 343, that was on our list, that was 7. You can find the cube root of a negative. The cube root of negative 125 is a negative 5. The reason for that, a negative times a negative times a negative, a third power on a negative is a negative. And the same way with the cube root of a fraction, you can find the cube root of the top and then the cube root of the bottom, which would be negative 1/3. Fourth roots, now you can't take the fourth root of negatives or you're going to end up with imaginaries here. Fourth root of 1 is 1. The fourth root of 2,401, which that should have been a plus or minus 1, because a negative 1 to the fourth is also 1. Again, the fourth root of 2,401 is plus or minus 7. And you can check that by doing 7 times 7 times 7 times 7, which is 49 times 49, which does give you that. Fourth root of 4,096. You can type that into your calculator, but you'll find out 8 to the fourth power gives you that, so a positive or negative 8. And then the fourth root of 81 over 16 would be a positive or negative. Find the fourth root of the top. Now let's think about this. To find a fourth root, can't you find a square root and then square it again? Square root of 81 is 9, square root of that is 3. And you could check that by saying is 3 times 3 times 3 times 3. Well, that's 9 times 9, which, yes, is 81. So the fourth root of 16 on bottom is 2, so plus or minus 3/2. So therefore, when our index, let's talk about this. When our index, a reminder, the index is the number out here. and the radicand is the number inside of here. When your index is an even number, going back to these, and that would be this situation or this situation, and you have a positive radicand, which all of those are positive, then you're going to have what type of roots? And that would be real. You can find the square root and the fourth root and the sixth root of positive values, and you're going to have two of them. They're going to be positive or negative. Now, when your index is odd, which is this situation, when your index is odd and the number under your cube root or fifth root, the radicand in there, when the radicand is positive, you will also have real answers. How many will you have? Only one, because like the cube root of 8 up there was only 2. It wasn't 2 and negative 2. Now, here's the other situations. When the index is odd and the number under there is negative, you will still get real solutions, and there will still only be one. So third roots, fifth roots, and so on and so forth. And then your special situation. What if your index is even, as it is here, or as it is up here, and the radicand is negative, like the square root of negative 16? Well, we've done those. That's when you have your imaginaries. The square root of a negative, the fourth root of a negative, and so on and so forth. And how many of those will you have? You'll have two. You'll have a plus and a minus. And let's make a note, and something I said a while ago, if a radical has more than one root, the radical sign indicates only the principal root. Where if we ask you what's the square root of 117, we're only asking you for the positive version, even though we know there's two different things, like root 117 will have two different answers, a positive and a negative answer. But if we don't specify, we're only asking you for the positive. So therefore, let's simplify some of these radicals. And the way that we're going to simplify a radical is you're going to break it apart. And we did this in some of your other classes. We're going to break the 117 into something that you know the square root of. I don't know the square root of 117. You can test it. We're not sure. So we do have a list up above of things that we know the square root of. 4, 9, 16, 25, 36, ... We're going to take that 117, and one at a time, we're going to divide by 4. We're going to divide by 9. We're going to divide by 16 until we find something that will divide into that 117 that we know the square root of. And when you divide 117 by 9, you find out that it will divide evenly, and you get 13. So what does that mean? That means that I can split the square root of 117 into the square root of 9 times the square root of 13. Now, why would I want to do that? Because we're simplifying it. The same way you simplify fractions, you need to simplify your radicals if at all possible. Because now, since I know that 117 is the square root of 9 times the square root of 13, I can rewrite this as the square root of 9 is 3, and I do not know the square root of 13, so I leave it. So the square root of 117 simplified is 3 root 13. Number 2, if there's a number out front, we leave the number. We're going to take the square root of 320, and we want to find the largest number inside of that 320 that we know the square root of. So we take it, we start dividing by 16, we start dividing by bigger numbers. And let me show you something. 16 actually works, but there's a problem here. If when you divide it, you come up with something that has another radical inside of it. The square root of 20 has another number in there. It has a 4. That means there's a larger number that you could have divided that you know the square root of. There's a larger square root that you know inside of that. Now, if you see that there's a 4 in here, to figure out what that larger number is, you can actually multiply the 16 by that 4, and that's going to tell you what it is. And that's going to tell me, again, I could have split this into the square root of 64 times the square root of 5 instead. So now let's mark that out. That would be 4 times square root of 64 is 8 times the square root of 5. And what we're going to do now is simplify this. 4 times 8 is 32, and just leave the root 5. Number 3, now we're dealing with third roots. Now let's make a list again of all the things. It's listed above, all the things you know the third root of. 8, 3 times 3 times 3 is 27. 4 times 4 times 4 is already too large. So one of these would have to work. So we're going to split this into 2 times the cube root of 8 times the cube root of 6. And you do not know the cube root of 6, so therefore it's going to stay. However, the cube root of 8 is 2. So you now have the 2 times the cube root of 6, which is 4 times the cube root of 6. Now be careful about where you write that cube root symbol, that index, because if you write it too close to the 4, it turns into 4 to the third. It looks like something different. Again, let's take these numbers here and try to find something that will divide into the 108. When you do 108 divided by 27, we learn that you get 4, so that we're going to split this into the cube root of 27 times the cube root of 4, which would be 3 times cube root of 27 is 3 times the cube root of 4. 3 times 3, that'd be 9 times the cube root of 4, and you don't have to put that dot if you don't want to. You could just put 9 cube root of 4. Okay, number 5, we see here a cube root of a negative. Now, as I break this apart, I am going to break it into the cube root of negative something to kind of pull that negative out of there. The cube roots, again, that we know is 2 to the third, 3 to the third, 4 to the third, and 5 to the third is 125, which I believe that would work. So I'm going to split this into the cube root of negative 125 because I can find the cube root of a negative. So I'm going to go ahead and, again, pull that out, and cube root of 2 is going to stay. The cube root of negative 125 is a negative 5, and I do not know the cube root of 2, so it stays negative 5 cube root of 2. Cube root of negative 2 here, I'm bringing the 6 down, and I'm going to split this into something I know the cube root of, and negative 2 can only be split into negative 1 times 2. Same way you do when you deal with imaginary numbers. However, I do know the cube root of negative 1. So that gives me 6 times cube root of negative 1 is negative 1. You can find the cube roots of negative, so that's legal. So that's going to be negative 6 cube root of 2. Number 7. A fourth root now, the numbers I know fourth roots of. And notice I don't put 1 because it's not going to help if you break it into 1 times something. So you have 2 to the fourth. You have 3 to the fourth, which is 81, and you have 4 to the fourth, which is 256, which is already too big. 81, when you divide, will give you a 2. So we're going to split it into 3 times. The fourth root of 81 times the fourth root of 2. The fourth root of 81 is 3. So you now have this. 3 times 3 would be 9 times the fourth root of 2 is the simplified version. Number 8. Man, we got a large number here. We've got to find some fourth root that'll divide into 2,592. So we're going to split it into, and you can just start dividing by the list of fourth roots that we know, and you're going to find out that it is divisible by 1,296. We're going to split it into 1,296 times 2. And the fourth root of 1,296 is 6. So we now have 5 times 6 times the fourth root of 2, which is 30, times the fourth root of 2. Next up, radicals with variables. Now, square roots. Let's talk about some variables that we can take the square root of. Again, remember what a square root is. It's what multiplies times itself to give you that. And I know the square root of x squared would be x, because x times x will give you x squared. And I could do the square root of x to the fourth because of my rules of exponents. I know x squared times x squared is x to the fourth. The square root of x to the sixth, well, x to the third times x to the third will be x to the sixth. And notice the pattern there. I can only find square roots. The exponents must be multiples of 2 to find a square root of it. With a cube root, it kind of works the same way. The cube root of x to the third would be x. The cube root of x to the sixth. What multiplies by itself 3 times? That'd be x squared, and x squared. That'd be 6x's. You're only going to be able to find a cube root. Exponents must be a multiple of 3. And a fourth root, the exponents would have to be a multiple of 4. So that's going to tell you what to split these into. So as I do number 9, I'm doing a square root. Remember that you're going to have to split your exponents into something that is a multiple of 2. So I'm going to actually write this as 3 separate problems. Root 32, root x to the fourth, and root y to the ninth. Root 32 is the old stuff. That's what we've been doing. Let's split it into 16 times 2. Root x to the fourth, since x to the fourth, since that exponent is a multiple of 2, I can leave it. Y to the ninth is not a multiple of 2. So I'm going to have to split this into something that I can take the square root of. You want the largest multiple 2 that is smaller than 9. That's going to be y to the 8th. Y to the first is what you're going to split it into. Y to the 8th times y to the first. Again, I want a multiple of 2 that I can find the square root of. Now, pretty simple. Everything that you know the square root of there, let's go ahead and simplify. I know the square root of 16. That's 4. I know the square root of x to the fourth, that's x to the second. I know the square root of y to the eighth, that's y to the fourth. The things I don't know the square root of, they stay. I didn't know the square root of 2, and I did not know the square root of y to the first. So those two things stay underneath there, and there's your answer. Okay, number 10. Again, I like to split these into 3 separate problems. Root 324, root a to the third, so you can put a big dot there if you want to, and then root b to the seventh. So 324, we're going to split into, well, we might actually know the square root of 324. And you can check it if you'd like to. It's 18, but we know the square root, so we don't even have to split that. However, a to the third, we're going to split into the square root of an even. Again, if you remember what I said a while ago, it must be a multiple of 2. So we're going to split that into a to the second, the largest power smaller than 3, that's even, and then square root of a to the first. And then b to the seventh, we're splitting into the largest even number would be b to the sixth, and b to the sixth times b to the first is give you b to the seventh. So we know this square root, and this square root. Let's clean those up. Square root of 324, 18. The square root of a squared is plain a. The square root of b to the sixth would be b to the third. The stuff that's remaining under the square root are here and here, which is another a and another b, and you are done. Number 11. Now we're doing some third roots. So let's split this into the third root of 216, a third root of m to the third, and a third root of n to the sixth. Now let's remember what we said about third roots. To take a cube root, exponents must be a multiple of 3. Now notice with this problem, luckily, every one of these exponents are multiples of 3. So they're things we can take cube roots of. So let's look at the 216. We can actually take the cube root of it as well. So we know all of these. Cube root of 216 is 6. The cube root of m to the third is m because m times m times m, 3 of them would give you m to the third. The cube root of n to the sixth would be n to the second because n squared times n squared times n squared would give you that n to the sixth. Number 12, again, split it three ways. The cube root of 56, the cube root of r to the eighth, and the cube root of s to the fourth. We're looking for multiples of 3 on our exponents. However, on the 56, I know the cube root of, again, 8. I know the cube root of 27 and so on. So I'm going to do it as an 8 times a 7, cube roots. The cube root of r, that's supposed to be an eighth here, r to the eighth power. I need a cube root that's a multiple of 3. So the largest power, smaller than 8, that's a multiple of 3, would be r to the sixth. So let's split it into r to the sixth and r to the second. That'd give you r to the eighth. S to the fourth, I need a cube root of s to the third, which is a multiple of 3, and s to the first. So I know this, and I know this. Cube root of 8 is 2. Cube root of r to the sixth is r to the second. Cube root of s to the third is plain s. And then the cube roots that you don't know, you can put a dot if you'd like to keep that s and that third power separated. I don't know the cube root of 7. I don't know the cube root of r squared, and I don't know the cube root of s, so those things will stay underneath as I simplify. Let's do another one. Cube root of this. And always factor that negative out along with it. So I know, let's split them into third root of negative 64, the third root of x to the 10th, and the third root of y to the 21st. Let's find a power or a number that I know the cube root of in that negative 64. And we can find the cube root of negative, so we can split it into negative 8. Well, hang on. We actually know the cube root of negative 64. We do not have to split that, so scratch that. We know that cube root. Cube root of x to the 10th, let's split into the cube root of, it must be a multiple of 3. So the largest number that's a multiple of 3, smaller than 10, would be 9. So let's split it into the cube root of x to the 9th and x. And then we actually know this cube root because it's a multiple of 3 as well. So we know the 3 here that I have circled. The cube root of negative 64 is negative 4. The cube root of x to the 9th is x to the 3rd. The cube root of y to the 21st would be y to the 7th. And you can check that. Y to the 7th times y to the 7th times y to the 7th would give you that 21. There's 3 of them. And then the cube root that stays would be just the x. And again, you can put a dot there if you'd like to keep those separated. Number 14, split it. Cube root of negative 81. You don't know that, so we will have to split that. The cube root of p squared and the cube root of q to the 12th. Cube root of negative 81. Now you do know negative 27, which is inside of that 81, so let's split it into that times 3. Cube root of p squared. There's no number that's a multiple of 3 that's smaller than 2. So therefore, we're just going to have to leave it. And we actually know this one already, so we can leave it as well. So the cube root of negative 27 is negative 3. The cube root of q to the 12th would be q to the 4th. And then you still have a couple of things left under the cube root. That would be a 3 and a p squared. Number 15, fourth roots. So we're looking for, when we're dealing with fourth roots, let's scroll back up and just remind you, you probably already know, fourth roots has to be a multiple of 4. Fifth roots would have to be a multiple of 5. Sixth roots have to be a multiple of 6, and so on and so forth because of those rules of exponents. So we're going to split it into the fourth root of w to the 4th times the fourth root of v to the 17th. Now this one we already know because it's a multiple of 4. Now we're looking for a multiple of 4, though, smaller than 17. That'd be the fourth root of v to the 16th. So we'll split it into that times v, and we know this now. The fourth root of w to the 4th is plain w. The fourth root of v to the 16th would be v to the 4th times the fourth root of v is going to stay underneath. Okay, number 16. The numbers that we know the fourth root of, we know that 2 to the 4th is 16, 3 to the 4th is 81, and that's already way too big. So more than likely 16 is going to work. Fourth root of 48 times the fourth root of m to the 8th, which we already know because that's a multiple of 4. And then finally the fourth root of n to the 3rd. 48 can be split into the fourth root of 16 times 3. And we know the fourth root of 16, so I'm going to circle it. I already know the fourth root of m to the 8th. And the fourth root, since it has to be a multiple of 4, there's not a number smaller than 3 that you can split this into that's a multiple of 4. So we're just going to leave that. So the 2 that we know, the fourth root of 16 is 2. The fourth root of m to the 8th is m to the 2nd. Times the things that stay underneath would be the 3 and the n, well, hang on. Yeah, the 3 and the n to the 3rd. That's it. Number 17. Another fourth root, and I think we actually know the fourth root of 625, so no simplifying will have to be done there. Times the fourth root of c to the 23rd needs to be a multiple of 4. And the fourth root of d to the 11th also needs to be a multiple of 4 that we split it into. So we know this one already. That's on our list. The fourth root of c to the 23rd, we're going to split into a number smaller than 23 that I know that's a multiple of 4 is 20. So let's split it into c to the 20th and c to the 3rd. And then d to the 11th, let's split it. I know that a multiple of 4 that's smaller than 11 would be d to the 8th. So let's split it into d to the 8th and d to the 3rd. So I know these 3 that I have circled. Fourth root of 625 is 5. The fourth root of c to the 20th is c to the 5th. And you can try that out by raising that to the 4th power. And power to power, you would again get c to the 20th. So that does check out. The fourth root of d to the 8th would be d to the 2nd. Times the things that stay underneath would be a c to the 3rd and a d to the 3rd. And the last one. We have a fourth root of something raised to an 8th power. Now this one's unique. And if you want to, this stuff raised to the 8th power, you can think of as being a different variable, smiley face to the 8th. Can I find a fourth root of something raised to the 8th power? Yes, it's that stuff raised to the 2nd power. So therefore, what we can do here, it looks complicated. It's a lot easier than it looks. But the fourth root of something raised to an 8th power, since it's a multiple of 4, it's going to be that same stuff to the 2nd power. A fourth root of an 8th power would be a 2nd power, the same material. And you can leave it like that, or you could actually square it out either way. So either one of those answers would be fine.